Hello, class. Welcome to Hazily Maths online class. My name is Li Hui Jing. I will be your mathematics lecturers for this semester. For mathematics SM025, basically, we have 10 topics as shown below. So, for the first five topics will be more on the calculus. For the second five topic will be more on statistics. Okay, so today we are going to concentrate on chapter 1. So basically, chapter 1 integrations have 4 subtopics as integrations of functions, integrations of trigonometric functions, technique of integrations, and definite integral. So in chapter 1.1 integrations of functions, we're going to know how to relate the integrations and differentiations. And we have to define the basic rules of integrations, and finally we have to find the integral of functions of exponents and the function of 1 over ax plus b. So before we proceed, so the basic idea is that we must know integrations is the process of antiderivative. I hope that you still remember what it means by derivative. We differentiate the x squared, so we will have 2x. So 2x is the derivative functions and the x squared is the antiderivative. If you look at this case, so the derivative of x squared minus 1, so we also will get 2x. So again, so 2x is the derivative functions and the x squared minus 1 is antiderivative. If we proceed to x squared plus 2, we also will have 2x. So again, so 2x is our derivative and the x squared plus 2 is our antiderivative. So you will notice that, okay, so these functions, so let's say this x squared you may plus a constant 0 minus 1. So they were going to different and the constant only, and they have the same family functions of x squared. So therefore, since the integration is reverse process of differentiation, so you must say that, so if I do the integral, you will get the function of quadratic x squared with plus any constant. So I think that if we integrate, this one also will get quadratic function, this one also will get quadratic function. This is why when we do the indefinite integral for the 2x, so we are going to have the x squared plus a c. C is the constant. Okay, c can be any constant, and you must make sure that everything we will have the same family of quadratic. So this is why the derivative functions, when you differentiate, you get a function of x. So when you integrate both sides, so with respect to x, so you are going to get back your fx. This is why the integral of fx dx is equivalent to fx plus c. So this is a constant. So they are the reverse process. So here is some basic rule of integrations that you have to keep in your mind. Derivative of kx, so we have the k, therefore the integral of k with respect to dx, so we have the kx plus c. So if we do the differentiate of x to the power n plus 1 is equivalent to n plus 1 to the power multiply x to the power n. So this one we bring down the power, and the power is subtract with 1. That's why I get n plus 1 and x to the power n. So if we use the integrations, so therefore the integral of the x to the power n, so you're going to have x n plus 1 over n plus 1. So this one you have to keep in your mind is that you must add 1 to the power first. Okay, and only you divide the n plus 1, the power. After you add n plus 1. So they are the reverse process. So if we do the differentiation, so we bring down, we multiply first and only we subtract. So for doing the integration, so we have to add first and only we do the divisions. Okay, so if we have the differential of ax plus b, so we will get the n plus 1. So we bring down the power. So the power is subtract with 1 multiplied with a. So therefore, if you integrate the ax plus b for power of n, so we have the ax plus b, add the power first, you add the power by 1, and you divide by the n plus 1, multiply with the differential of ax plus b, that's why you will get a. So for these cases, you must take note that this one should be a linear function. So should be a linear function. Okay, so we proceed off. The next two property is that the integral of k fx will equivalent to the k multiplied with the integral of fx. And if we have the operation of plus minus here, so they are going to follow through. Okay, so let us look at some exercises as these. So the integral of x to the power of 4, so we apply the basic rule of integrations. So we add the power first and we divide the power by adding 1. So that is why we will have the answers of 1 over 5 x to the power of 5 plus the c. Since this is the indefinite integral, that means they don't have any limits here. So you must remember to add on the constant. Okay, so we proceed with the second one. 1 over 3. So we do the same procedures, same process. So we add on the power first. And if we divide by the power 1 over 3 plus 1. So we simplify it. So we have the answers. And proceed with the third one. See if we have the power of minus 1 over 2 also. We just do the same process. So remember, we must add 1. Okay? Add 1 to the power. And then only you divide. Okay? Only you divide. Okay, so we do the same process. We add 1 first. And we divide by the minus 1 over 2 plus 1. So kita bring down here, kita divide. And you simplify. So you will get the answers. And finally, for the third case, so we try to convert in the index form first. So this one, if we convert, so we have the x to the power minus 7. So that's why minus 7 plus 1 over minus 7 plus 1. So I will have the negative 1 over 6x to the power x, 6 plus c. So this is how we do the basic integrals. Okay, let us proceed to the second example. So if we look at this question, so before we do anything, so we try to change this into the index form first. So we have the x to the power of minus 2 here. So that's why when you differentiate, so 1 by 1, so we have the 2 x to the power of 2 plus 1 over 2 plus 1. So this one we just bring down from here. And the next one is plus the x to the power minus 2 plus 1. The index or the power plus 1. So divide by the power plus 1. And x, so x is plus 1. 1 plus 1 you get 2 over 2 plus the c. So after that you just simplify. So get the 2 over 3 x to the power of cube plus 1 over x plus x squared over 2 plus the c. So same cases here. So we try to convert in the index form. Third, we will have the x to the power 1 over 2. And this one we have the 2 x to the power negative 1 over 2. So for these cases, okay, so we proceed to integrate 1 by 1. So we have the x to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1. So 2x to the power negative 1 over 3 plus 1 divided by minus 1 over 3 plus 1 plus integral of 2, you get the 2x, then plus the c. Okay, after that you just simplify and you will get the final answers as this. So I hope that you can go back and try your tutorial questions. Okay, so do more practice on this. So we proceed to the questions number C here. So before we doing the integration, so let us change this into the index form of x to the power 1 over 2 first. So we have the answers of this. So this one is the same as the previous one. Okay, so what we want to see is the examples D here. So before we do anything, so we have to start to think. So for integrations, there is no quotient rule. Okay, I repeat, in integration there is no quotient rule. So what you need to do is that you have to simplify this as the single term first before we proceed. Okay, so what I mean is that, so we have to simplify the term one by one. Okay, after that, only you start to integrate. So this one you simplify. Okay, so that means that for these cases, for example, for the first cases, so we have the x2, so minus 1 over 2. That's why I get the x to the power 3 over 2. That's why you will get this term. Okay, same thing is that for the second term. So we have the x power of 1 minus 1 over 2. Since it's a division, so we just subtract the power. So we get the 1 over 2 here and so on. Okay, then after that, only we apply the rules of integrations. Okay, and you simplify it and you will get the final answers. So I hope that after this, you can go back and try. Okay, so for the third example, so we have to, okay, so the rules of the integral of ax plus b. So before we do anything, so we have to make sure that if you want to apply this rule, so you must make sure that the function, the inner function is a linear function. Okay, only you can use this formula, is it? Okay, so first of all, if we look at this question, so we have the 2x minus 1 to the power of 2. So we notice that this is a linear function. Okay, only we are allowed to apply the formulas. Okay, so we will have the 2x minus 1. So the power we add 1, so that's why you will get 3. Okay, divided by power. And this one, the 2. The 2 is how you get the 2. 2 is the differential of the 2x minus 1. So you will get 2. That's why you have to divide by the process of differentiations. Okay, so that's why you have the divided by 2. Okay, so you will have these answers. So previously in the differentiation, so we multiply with the differential. Okay, for integration, you are going to divide. Okay, divide the integral of 2x minus 1. Okay, I hope that you can do more practice and familiar with this. Okay, so for the next questions also, so why we can apply this is because, so if we look at these questions, so we know that, so this is still, we consider it as the linear function. Okay, so because, so this one we can simplify f2 minus 5x to the power of 1 over 2. That's why we can add up the power. Okay, and divided by 1 over 2 plus 1, multiply the minus 5. How you get your minus 5 is that you differentiate your 2 minus 5x. So you get a negative 5. So that's why you will get this. Okay, clear? Okay, so only you simplify, then you will get the final answers of this. Okay, for the example C, so I give you some time to try this first. So before we doing anything, so we try to convert this into the index form. So we will have the 2x plus 1 to the power of minus 3 and 1 minus 2x to the power of 1 over 2 dx. Then only you start to integrate. Okay, so we double check first. So this one is the linear and this one is also a linear functions. Okay, so we can start to integrate by using the basic rule of integration. So we just add on the power, divide by the power plus 1. Okay, and the 2 will come from the differential of 2x plus 1, you will get 2. Okay, same cases here. So we add on the power, we divide by the power and divide by the differential of the 1 minus 2x, so we get a minus 2. So we try to simplify it to get our answer. So this is basically a basic rule for the polynomial or the linear polynomial. Okay, now we try to proceed the integrations of the exponential form e to the power x or a to the power x and the term of 1 over x. So if you still remember during the process of differentiations, you differentiate e power x, you will get the e power x. Therefore, the integrations of e to the power x dx, you will get back your e to the power x plus c. And if you have the e power ax plus b dx, so you're going to have the e power ax plus b over a. Okay, so for these cases, so I want you to take note is that you must remember that the power, okay, please write it out. Okay, the power here should be linear. Okay, again, okay, the power here for the exponents, it means bilinear. Only you can apply this formula, e power of x plus b over a. Okay, so we proceed with the exponent ax. So we differentiate, we get a power x ln a. So this is why the integral of a power of x. So we have the a power x over ln a. Okay, so if you have a power mn mx plus n, so you have the a power mx plus a plus n over m ln a. Okay, how you get this m? M is the differential of mx plus n, so you will get the m. Okay, so during the differentiation, you multiply with n. So in the integration, so you have to divide. Okay, so you have to divide. Okay, so all these formulas you have to memorize. Okay, so we proceed on the last one is the ln. Okay, differentiate the ln x, you get 1 over x. This is why the integral of 1 over x dx is ln absolute of x plus e. Okay, so this is the special cases. Okay, for the n is power of minus 1 only. So 1 over x. So the rest, so you must use the basic formula integral. So if your power of n is minus 1, so you are going to get ln. Okay, so after this, in the chapter 1.3 only, I will start to discuss with you why we have to put modulus here. So this one will be useful when you do the definite integral. Okay, so that is why if I have the 1 over ax plus b, so again, so please use your highlighter to highlight. So this one means for the linear functions. Linear function. So only you have the ln ax plus b over a. So how you get your a? A is the differential of ax plus b. So equivalent to a. Okay, ln ax plus b over a plus the c. Okay, this is all the basic formulas for the integrations of exponential functions and the functions of 1 over x or function of 1 over ax plus b. Okay, so we look at the examples for which we're going to apply the integral of exponential. Okay, so if you look at the first one here, so this is the exponent. So you have the e power of ax plus b over a. So for these cases, so the power is 2x, so it's a linear function. So this is why I will have the e power 2x over differential of 2x, you will get 2. That's why you're going to have 1 over 2 e power of 2x plus the c. So for the second example, so if you're already familiar with the formula, so you just differentiate. For x plus 1 in it, you differentiate, you will get 4, right? This is why you have the 1 over 4 e power of 4x plus 1. So if we have the power of 5 minus 3x here, so this one is still a linear function, so you differentiate, so you have the 4. Okay, so minus 4 over 3 e power of 5 minus n plus 6. So this is how we get. Okay, so this means that when I differentiate, I copy back my exponents. So I have the e power of minus 5 minus 3x divided by the differential of 5 minus 3x, you get a negative 3. That's why you get the minus 4 over 3 e power of 5 minus 3x plus c. Okay, clear? Okay, so finally, the examples is the 3 power of 1 minus. So this one we will have to use these formulas. So you just copy back your 3 to the power of 1 minus x, differential 1 minus x, you will get a minus 1, and ln 3 plus c. So this one basically is we use this formula. Okay? So we proceed to the example E here. So before we do anything, so I repeat, for the integration there is no product rule. So what you need to do is that you have to expand first. So e power x multiply e power 2x, so you get e power 3x. So e power of minus 2x multiply e power 2x. So you have the e power minus 2x plus 2x, so you get the e power of 0. Okay, so before we do anything, you expand first. So e power 0, that's actually this is 1. So that's why only you start to differentiate as this. So we will have the e power of 3x, so get e power 3x over 3, and since the e power of 0 is 1, that's why I get a plus x plus the c. Okay, remember this one plus a constant, this is the indefinite integral. So and finally, if we have this, so before we do anything, so we just simplify first. So kalau divide, so dia tolak, right? Minus, so you get e power of minus 2x. So for these cases, e power 2x minus x, so you have the e power x. So this means you simplify first, then only we start to differentiate. So our final example is the example on the integral of 1 over ax plus b. So I will get the answers of ln. So first of all, so we just look at this one. So this is a linear function. So this one, I will have the 1 over 2 integral of 1 over x dx. That's why I get 1 over 2 ln x plus c. So we may do is, or you may write a 1 over 2 ln x plus c. So after this in 1.3 only, I will discuss why we have to put a modulus. Actually, this is useful when we want to evaluate, okay, the value for x, especially for the definite integral which involve the value of negative. Okay, so for these cases, example B, we have the 3x plus 1. So again, so this is the linear. So I have to apply this ln ax plus b over a. So this one, if I differentiate 3x plus 1, so I will get a 3. So that's why I will get a 1 over 3. So if I differentiate, so I get a 1 over 3 ln 3x plus 1 plus the c. So, and finally, we look at this. So this is a linear. So if I differentiate, so I'll get the negative 3 over 2 ln 1 minus 2x. So because when you differentiate 1 minus 2x, so get a negative 2. That's why I get a negative 3 over 2 ln 1 minus 2x plus c. So basically, this is what we have for this chapter 1.1. So please kindly rewatch this video and make sure that so you understand. After that, you have to do this exercises 1, answers all the questions and submit to the Google Classroom before the due date. Okay? If you have any questions, so please ask me or have the consultations with me, so I will try to help you to answers. So please enjoy your exercise here. So again, so do remember to do it and submit to me before the due date. So thank you very much.